Okay, we're going to talk about how electrons are arranged in atoms. Now, just to remember GCSE, we would say we would write, if we had a hydrogen, we've got the nucleus, yeah, the hydrogen nucleus there, and we've got the first shell, I've got one electron in there, and we said then you've got helium, yeah, you have got 2 electrons in the shell. The next element after helium is lithium, where you've got 2, okay, and then we'd say that the first shell is full up, and in lithium you've got 2 electrons in the first shell, and you have got 1 electron in the outer shell. That's what we'd say, and we'd represent that. We'd say 1, 2, and we'd say 2, 1 for that. Okay, now we're going to stop thinking of electrons as little point charges orbiting the nucleus. Instead, we think electrons are they are negative charge cloud. Okay, they're a cloud which is negatively charged. Okay, but they're not just, these clouds can't take any old shape. They're only allowed to take certain shapes. And these shapes are called orbitals. There's certain predefined shapes that they're allowed to occupy. Another little rule is, we're going to say that each orbital can only fit 2 electrons in there. The next thing we need to think about is this very peculiar concept, this property of electrons called spin. Okay, and spin, it's analogous to them spinning around, but it doesn't mean that they're spinning around. It's a mysterious quantum mechanical property, and it can have 2 values. It can have either, it can be up or that, or it can be down. And when you have 2 electrons in the same orbital, they have opposite spins. One has up and one has down. They've got to have opposite spins. Okay, so we're going to talk about there are what do these orbitals look like. Okay, the 2 we want to talk about in that today, they're called the 1s orbital, and that is the lowest energy, that's closest to the nucleus. The 1s orbital, that's a sphere, okay, with the nucleus in the middle. And then the next one is called the 2s orbital. That is also a sphere, but it's slightly, quite a lot bigger than the 1s. It's further away from the nucleus, which is at the center. So all we're going to think about is the first 4 elements of the periodic table in this video. We're going to think about, so they are hydrogen, helium, lithium, and beryllium. Okay, let's think about hydrogen. Hydrogen then is going to have 1 electron in the 1s orbital. Helium is going to have 2 electrons in the 2s, but they're going to have opposite spins. Then with lithium, that's going to be full up, so now you have to start filling up the 2s orbital. So lithium is going to have 2 electrons sorry, I should say 1s. Yeah. Lithium is going to have 2 electrons in 2s, 1s, and it's going to have 1 electron in 2s. And finally, beryllium is going to have 2 in 1s, and it's going to have 2 in 2s. Now, how would we write that in shorthand, right? So this is the shorthand we used to use, which is 1, 2, 2, 1. Well, we write this down as 1s1 to show there's 1 electron there. This one here we write down as 1s2 to show there are 2 electrons in the s orbital, 1s orbital. Then we'd write 1s2, 2s, 1s1, and here we write 1s2, 2s2. That's how we've represented it. And that's how the electrons are in the first 4 elements of the periodic table. After that, it gets a little bit more complicated, and we'll cover that in the next video. So, but before we do that, I just want to show you how we can represent this in terms of energy. So here, if you like, we're going to put energy. And what kind of energy? Well, it's potential energy, really. Electrical potential energy. And it's higher up that way. So I'm going to put, here's the 1s orbital there. And here is 2s orbital. So in hydrogen, when we're representing an electron, we'll draw, this is going to be an electron as an arrow, and the arrow shows you the direction of the electron's spin. So in hydrogen, the electron, okay, is going to, well, it will get as close to the nucleus as possible. It will fall down towards the nucleus. So where's it going to go? It's going to end up in 1s. So draw it like that, little arrow going up. Now, when you've got, that would be for hydrogen. Hydrogen, not helium. For helium, you've got 2 electrons. So the second electron would come, that would get close to the nucleus it can, so that would fall down into 1s, but it would have to have an opposite spin. It's not allowed to have the same spin, so that would look like that. Helium, that's how you represent the electronic structure there. When we get to beryllium, right, here's the electron coming in again. So, lithium, should we say? And it can't go all the way down to 1s now because that's full up, so it's got to go in 2s. So we have a spin like that, and so that's what lithiums would look like. And finally, if we go to beryllium, well, another electron would come down, wouldn't it? And it would go there, and it would have the opposite spin to the 2s. Right. So I think what we before we move on to the next video, I'm not going to tell you what the next orbital looks like, but it's actually, we'll tell you what it's called. It's called the 2p orbital. It's a different shape. And there are actually 3 2p orbitals, and they've all got the same amount of energy. And they're pretty close. They're a little bit higher in energy than the 2s, but not far off. And there's 3 of them. So I'm going to draw 3 lines there. So which element comes after beryllium? Well, it's boron. Okay, it's got 5 electrons. So in boron, one of the electrons would go into one of the, there's 3 orbitals there, you go into one of them. Okay, and we'll see what happens in the next elements in the next video. But for now, we'll just concentrate on that idea of electrons being not point charges, but clouds, but those clouds are only allowed to adopt certain shapes. We've looked at 2 of those shapes for orbitals. We looked at the 1s, which is a sphere, and we looked at the 2s, which is a bigger sphere.